be there today to teach you this one, but it's a pretty easy topic, so I'm gonna just share with you this short video I made to kind of help you guys understand it. The topic is wave speed. It's kind of exactly how it sounds, but I'm gonna walk through some of the components of it and eventually a mathematical formula for it. Should be pretty simple. I think you can do it. I believe in you. Here we have a simulation called Wave on a String. It's a PhET simulation that we can use to understand some of the basics of waves and how waves interact. So we have this little bob that goes up and down, creates waves. We can slow down the wave. We can pause it, all in a way to kind of understand and use different tools to help us understand how waves interact. We have crest and the trough. And so we're going to be kind of playing around with this a little bit. Part of a wave that we're going to be referencing is the amplitude, as you can see down here. Right now it says the amplitude is 0.75 centimeters. So what I'm going to do is I'm going to put this little reference line here to see what it is. Basically, amplitude is how tall the wave is from the reference line, that little middle line in there. It's also called the origin, that middle line. And so what we're going to do here is we can change the amplitude. Basically, you just see the wave gets taller, the crest gets higher, or the trough gets lower, however you want to look at it. Or we can lower the amplitude, and the wave gets a little bit shorter in height above and below the reference or origin line. This next part is going to be about wavelength, which is basically the length of a wave. And so what we're going to do here is we're going to pause it so that we can look at it. Basically, it's going to be measured from the crest to crest or trough to trough. So right here I got about a wave of a wavelength of about 2.5 centimeters. That's basically how long it is from crest to crest. Now it should be also the same from trough to trough. Now what I'm going to do here to actually change the wavelength is I'm actually going to have to change the frequency here, which we'll talk a little bit more about in a moment. So if I let this run for a second, get a couple waves in here, pause it, and now the wavelength is a little over 1 centimeter. The waves are much closer together, they're much more compact. And if I have a very long wavelength, as you see here, it's going to take a second for all the waves to come in, is now we have the waves very, very spread apart over 3 centimeters. So wavelength is just how long the wave is from crest to crest. Alright, this last part is about frequency, which is actually probably one of the harder ones to understand. Frequency is the number of waves per second. It's how many waves pass a certain reference point every second of time. So the reference we're going to use today is this window. We're basically going to count how many waves pass through this window in a certain amount of time. To do that, we're going to actually turn off slow motion. And we're going to count, the easiest way to do this is count the number of crests that pass a certain point. Alright, so we have a certain frequency that's setting here, and when I lower the frequency, now I have a really long wavelength. Less waves are traveling through the window every second. And if I increase the frequency, that's a lot of waves, a lot of crests passing per second through the window. This would mean a high frequency. Now on to wave speed, like I said earlier, is basically what it sounds like. It's the speed of a wave, the distance per second that it travels. But because of the properties of waves, it's calculated a little bit differently. It's not just the delta x over delta t. You have to do some fancy mathematics. So here we go. Here's some fancy math, and voila, our wave speed formula. That's wave speed, the little v, just like for velocity, equals the lambda, or wavelength. Wavelength is represent the Greek letter lambda, times frequency. It's a straightforward math. Speed is equal to wavelength times frequency. So the units for this formula, we have wave speed, which is in meters per second, because it is still a velocity and speed. And then we have frequency, which is actually measured in hertz. As you can see at the bottom there, it's represented with a capital H and lowercase z. And then times, of course, wavelength, which is measured in meters. It could be really any distance, but we typically use meters, so we can get that meters per second. For those of you who like to use the triangle to help with your mathematics, here are 3 versions of it just so you can help you solve for it to help you rearrange that formula. Of course, I will still always provide for you the original formula of wave speed is equal to wavelength times frequency, but it can't hurt to have the triangle to kind of help you out with some math. Well, that pretty much wraps it up. I hope it was pretty easy to understand wave speed. And I hope you enjoyed the video. I hope it was a little bit helpful to kind of explain it a little bit, including the parts about wavelength and frequency. I'm not going to lie, I'm pretty proud of it, just because I was able to put this together. I'm pretty proud of it. So if you didn't think it was a good video, first of all, don't be hating. And when I see you again, just maybe just try and make me feel better and say nice things, even if you don't really mean it. Just helps with my self-esteem. All right. So your task right now is, now that you've watched the video, is to kind of take notes on some of the things. I'm not there to tell you exactly what to write, but a couple things I might suggest is the wave formula, the units for the formula, and if you like using the triangle, writing down the triangle thing. Or if there's any other terms that were kind of you didn't know before going to this, or you don't think I'll be able to remember, that's your call. But I would write it down in your notebook, especially that formula, because even though I will provide it for you, it's still a good thing to have, including the units. And so now you're ready to move on to the next task, which is to do a little bit of practice. But and then we'll go from there. All right. Thanks for watching, guys. Appreciate it. Have fun.